And now we're in 3.3, which is dividing polynomials, the remainder and factor theorem. Here are our objectives. We're going to start by talking about long division of polynomials. Step 1 says arrange the terms of both the dividend and the divisor in descending powers of any variable. In this case, let me give you an example. We had x squared plus 2 minus x. Well, first of all, we have to put in descending powers. So the new way would be written as x squared minus x plus 2. And if we were missing a term, we will use 0 as a placeholder. So here's another example. Let's say we had x squared minus 1. Well, in this case, we're missing an x term. So we will rewrite this as x squared plus 0x minus 1. Then step 2 says divide the first term in the dividend by the first term in the divisor. The dividend is the polynomial that goes underneath the divide symbol, and the divisor is the polynomial on the outside. The quotient is your answer that's being formed on the top. So it's to divide the first term in the dividend by the first term in the divisor. The result is the first term in the quotient. Then you're going to multiply every term in the divisor by the first term in the quotient. So everything down here in the divisor is going to be multiplied by that piece that you just added into your quotient. Write the resulting product beneath the dividend with like terms lined up. And then you're going to subtract the product from the dividend. You'll be left with a new dividend. Of course, we bring down the next term. So remember, we bring down the next term. And you would continue the process. Now you're going to take the first term in the new dividend and divide by the first term in the divisor. And continue, and then you will multiply. So steps 2 through 5 will be repeated until you cannot divide anymore. The term left at the very end is the remainder. All right, let's go in our books to page 373. We're going to start by looking at number 7. It says divide using long division. State the quotient and the remainder. So number 7 has 12x squared plus x minus 4 divided by 3x minus 2. Alright, the first thing we need to do is make sure that the dividend and the divisors are both written in descending order with all of the coefficients present. If we had any missing, we will have to replace it with a 0. Everybody seems there. So this first piece of 12x squared plus x minus 4 is divided by, so it goes inside the divide symbol. And the 3x minus 2 is on the outside. Then it says take the first term inside the dividend. So this 12x squared is going to be divided by the first term in your divisor, which is 3x. So this is my side work. So 12x squared divided by 3x is equal to 4x. And that becomes the first term in the quotient. Then we're going to take this 4x and multiply each term in the divisor by it. So 4x times 3x is 12x squared. 4x times negative 2 is negative 8x. This is our product. And then we subtract all of this, right? So by putting the subtract sign, this makes the 12 negative and turns the positive 8 into a positive number. So 12 minus 12, well, that's gone. X plus 8x is now 9x, and you drop down the negative 4. This is your new dividend. Now you're going to repeat the process. You have 9x divided by 3x. So 9x divided by 3x. Still going to be the first terms. So 9x divided by 3x is just 3. So that's plus 3. And again, you multiply. So 3 times 3x is 9x. 3 times negative 2 is negative 6. Subtract, which means the 9 now becomes negative and the 6 becomes positive. These cancel out and this leaves you with a 2. This 2 is your remainder. So we have a remainder of plus 2 divided by the original divisor, which was 3x minus 2. So your final answer is 4x plus 3 plus 2 over 3x minus 2. All right, let's look at number 15. This time we have 18x to the 4th power plus 9x to the 3rd power plus 3x squared divided by 3x squared plus 1. So let's replace our missing terms here. We have the 4th power, the 3rd power, the 2nd. So we're missing the x term as well as the constant term. So we fill them in with zeros. And we're also missing an x term here. So let's fill that in with zeros as well. So that is plus 0x plus 1. Now we can rewrite it. So we have 18x to the 4th power plus 9x to the 3rd power plus 3x squared plus 0x plus 0, all divided by 3x squared plus 0x plus 1. And let me rewrite some of this. Okay, so we're going to take the first terms. I think I need more space. So you're going to take the first term in the dividend and divide it by the first term in the divisor. So 18x to the 4th power divided by 3x squared is 6x squared. And then you multiply each term, and the divisor will be multiplied by the 6x squared. So 6x squared times 3x squared is 18x to the 4th. 6 times a 0 is going to be 0x to the 3rd. You see how it's an x, and this is an x squared. And then 6x squared times 1 is plus 6x squared. Then we're going to subtract, which means 18 becomes negative, negative, and negative. These cancel. And now we have 9x to the 3rd power. 3 minus 6 is negative 3x squared. And then we'll bring down the next term, which was plus 0x. So now we have 9x to the 3rd power divided by 3x squared, which is just 3x. So this becomes plus 3x, and then we multiply. So 3x times 3x squared is 9x to the 3rd power. 3x times 0x is plus 0x squared, and 3x times 1 is plus 3x. And then subtract. Negative, negative, negative. These cancel. This becomes negative 3x squared. And a 0 minus 3 is a negative 3x. And then bring down the next term, which is 0. And then we're going to repeat it once again. So negative 3x squared divided by 3x squared is going to be negative 1. Negative 1 times 3x squared is negative 3x squared. Negative 1 times 0 is 0x. And negative 1 times 1 is negative 1. Again, let's subtract so the signs change. So this becomes positive, this is negative, and this is positive. These cancel out. This one leaves you with negative 3x, and this one will leave you with a plus 1. So this time our remainder is 2 terms, negative 3x plus 1. So I'm going to run out of room, so let me rewrite the answer over here. So your final answer will be 6x squared plus 3x minus 1 plus negative 3x plus 1, all divided by the original divisor, which was 3x squared plus 1. Okay, so there's one way that we can divide polynomials. We also can divide polynomials using the synthetic division. So let's go through those steps. So first thing it says, arrange the polynomial in descending power with a 0 coefficient for any missing terms. So if you have any missing terms, this time you must have a 0 coefficient. Write C for the divisor, where the divisor is written as x minus C. To the right, write the coefficients of the dividend. So what they're talking about is, if I say I'm dividing by x minus C, you're going to start by writing C. Okay, C is this piece that follows the minus sign. It has to be in this form. It has to say minus. So minus C. So you write C, and then you draw basically a box or a backwards L around him. And this is where you write the coefficients. Write your coefficients, and then put a horizontal line, a little space below. Step 3 says write the leading coefficient of the dividend on the bottom row. So this first coefficient drops down automatically, and he is written right here. And then step 4 says multiply C times the value just written on the bottom row. Write the product in the next column in the second row. So they're telling you that the value that you just put down here in box is going to multiply C. So C times box, and then you will write it, that resulting product will go under the next coefficient. Okay, then we add the product and the next coefficient together, and we get the new value, and we multiply once again, and continue the process. Then step 7 says use the numbers in the last row to write the quotient plus the remainder above the divisor. The degree of the first term of the quotient is 1 less than the degree of the first term of the dividend. So basically when they're saying, let me go back, your final answer written down here, you will have different values. The leading product or coefficient has a variable degree that is 1 less than the original dividend. Okay, so the best way to do this is work out a problem to explain this fully. So let's go to page 374, and we're going to start by looking at number 27. It says divide using synthetic division. So I have x to the 5th power plus x to the 3rd power minus 2 divided by x minus 1. Well, we notice that we're missing the 4th power here, the squared, and the x term. So let's rewrite this as x to the 5th plus 0x to the 4th plus x to the 3rd plus 0x squared plus 0x minus 2, all divided by x minus 1. So the first thing we have to do is make sure it's in descending order and use 0 as a placeholder for any missing coefficients. Then we look at our divisor. So this is our divisor. And we have to pull out C. So remember that it's in the form x minus C. So x minus C, which means C must be equal to 1. So write 1 and then put a backwards L around him. And then you're going to write the coefficients for the dividend up here. The first coefficient is a 1. So we have 1 and then 0, 1, 0, 0, negative 2. Draw a horizontal line. The first coefficient drops down, so there's our 1. And then we multiply. So 1 times 1 is also 1. Write it underneath the next coefficient and add these two. So 1 plus 1 is still 1. Multiply, we get 1. Add, we get 2. Multiply, we get 2. Add, we get 2. Multiply, 2. See, it's this new 2 times 1, which is 2. Add these together, and we get 2. Continue multiplying. Add these together, and we get 0. Once we did this process to all of each coefficient, we have our final answer. All we have to do is put it together. Now, the original polynomial or dividend had a degree of 5. So this answer has a degree of 4. It's 1 less. So this is x to the 4th plus x to the 3rd plus 2x squared plus 2x plus 2 with a remainder of 0. So basically, it's your coefficients in order for your answer. And all you gotta do is fill in the variable and the power. So this is our final answer. All right, let's look at number 31. And it has 2x to the 5th power minus 3x to the 4th power plus x to the 3rd power minus x squared plus 2x minus 1, all divided by x plus 2. So again, we have to make sure that it's written in descending order, and if we have any missing coefficients, we must place a 0 there. So we have 5, 4, 3, 2, 1, and this has a degree of 0. So that's fine. Next, we find the c. So remember, it has to be in the form x minus c. There has to be a minus sign here. So how can we rewrite x plus 2 so it has a minus sign in it? We will write it as x minus negative 2. Now we have the minus sign, which means the c is really negative 2, not positive 2. Write the negative 2, put it inside the backwards L, and write down the coefficients. So 2, negative 3, 1, negative 1, 2, negative 1. Drop the first coefficient, which is a 2, and then we're going to multiply. So 2 times negative 2 is negative 4. And then you're going to add these. So you get negative 7. When you get positive 14. And then 15. Negative 30. Negative 31. Positive 62. 64. Negative 128. Negative 129. It's a repeat. Drop down the first. Multiply. Write the new product here. Add, multiply, new product, add, multiply. And you repeat this. Once you have covered each coefficient, you're going to write your final answer. So this has a degree of 5, which means my answer must have a degree of 4. So this is 2x to the 4th power minus 7x squared plus 15x. Oh, I forgot one, I'm sorry. 2x to the 4th minus 7x to the 3rd plus 15x squared minus 31x plus 64. And this last number is your remainder again. So it's plus negative 129 divided by x plus 2. And there's your final answer. All right, so now we can talk about the remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of x. Let me go back. So if the polynomial f of x is divided by x minus c, then the remainder is f of x. The factor theorem. Let f of x be a polynomial. If f of x is equal to 0, then x minus c is a factor of f of x. Just think about, remember when it's equal to 0, you are finding the x-intercepts, right? Which means x minus c is a factor. If x minus c is a factor, then f of c equals 0. It's just a theorem that basically says what we've been working through, dividing polynomials, and whether it's a factor or not. All right, let's go in our books to page 374. We're going to start by looking at number 33. It says, use synthetic division and the remainder theorem to find the indicated function value. And it has f of x equal to 2x to the third power minus 11x squared plus 7x minus 5. And we must find it for f of 4. Well, we know we can evaluate this by just plugging in the 4. But let's see if we can use the remainder theorem and the synthetic division to actually accomplish this. So the first thing you want to do is use synthetic division to divide f of x by x minus c. Okay? Now, the question is, what is c? C is the thing that's actually being evaluated, f of 4. So 4 is c. So put the 4, and then put your backward L, and then go ahead and put your coefficients. Make sure they're in order, and it's in descending order. So 2, negative 11, 7, negative 5. Now we're going to go ahead and do the synthetic division. So we drop down the 2, and we get 8. Add these, we get negative 3. Multiply, negative 12. Add, negative 5. Multiply, negative 20. Add, negative 25. So now our new polynomial is going to be 2x squared minus 3x minus 5 with a remainder of negative 25. Okay, basically, and at this point, the second step says the remainder is equal to f of c. Or I could say f of c is equal to the remainder. So in this case, f of 4 is going to be equal to negative 25. And you can check that by taking this 4 and plugging it in. So f of 4, if we plugged it into the polynomial, it would be 2 times 4 to the third power minus 11 times 4 squared plus 7 times 4 minus 5. And I'll leave this to verify that you get, leave this for you to verify that you get negative 25. All right, so now let's do problem 43. So problem 43 says solve the equation 2x to the third minus 5x squared plus x plus 2 equals 0, given that 2 is a 0 of f of x, which is the polynomial I just read out. So all they want us to do is solve this. So this is number 43. And f of x was going to be 2x to the third power minus 5x squared plus x plus 2. And they said given that 2 is a 0. Okay, so the first thing you need to do is use synthetic division to divide f of x by x minus c. And remember, the c comes from the 0. So let's see, 2 backwards L, because 2 is the 0, here is the c. And in quotation, c is the 0. So they say 2 is a 0, so 2 is c. And then you're going to write in your coefficients like before. And let's use synthetic division. So you work this out on your paper and let's verify you get what I get. I'm going to go through the steps, pause the video, and make sure you can also work it out. And if you do, you should get new coefficients of 2, negative 1, negative 1, 0. The remainder is 0. If your remainder was not 0 for this problem, then you must go back and check yourself. Because remember, they said 2 is a 0, which means your remainder should come out to be 0. So now you have a new polynomial of 2x squared minus x minus 1. So 2 is a 0, and then you have this new polynomial, and now you need to factor him. Your choices for factoring him is to do it by hand, if it's possible, or to use the quadratic formula. Let me remind you of the quadratic formula. negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Or you can try to factor. This one does factor. It can factor into 2x, x, negative plus. So 2x plus 1 times x minus 1. And then from here, you can set it equal to 0 and you can solve. So we have 2x plus 1 equals 0 and x minus 1 equals 0. X in this case is negative 1/2 and x in this case is 1. So you just found x to be 2. Originally they gave you that, so x is 2. And then by solving the new polynomial, you get x is negative 1/2 and x is 1. So step 2 would be solve the resulting polynomial either by factoring or by using the quadratic formula. And remember, it's written as ax squared plus bx plus c. This is where you pull the a, b, and c. So in this case, a would have been 2, b would have been negative 1, and c would have been negative 1. And do not confuse this c for this c up here. Two different concepts, two different ideals. Okay, so this concludes the video for 3.3. Let me know if you have any questions.